we'll start with light, reflection and refraction today. In this chapter, we are going to see about the reflection, spherical mirrors, and we'll study the concept of refraction of light and the spherical lenses and the image formation of the spherical lenses and spherical mirrors. And we have magnification of spherical lenses and spherical mirrors and things. So in this session, we'll study about light. What is light? What are the reflection, laws of reflections? Then plane mirrors. This is just a recall session. So what is light? What do you think is a light? Yes, light is a form of energy. So when light is a form of energy, it should have a source, right? So what will be the source of this light energy? Yeah, so sun, the lights which we use for our daily life, the tube light, bulb, and other decorative lights that we use. Okay, so this light is a form of energy, and sun is an important source of light energy, because without sun we cannot distinguish between day and night. When we move on to the properties of light, what would be the properties of light? We have studied this in the previous classes. So can you tell me what are the properties of light? Yeah, light travels in a straight line. It travels in a straight line. When it travels, so it has a speed. So speed of light is, it's always a constant. C equal to 3 into 10 power 8 meter per second. It is so fast. Then it creates shadow. Okay, it creates shadow. It has a dual nature. That is, light can behave as a wave and as a particle. It has a dual nature. It can be particle and wave. Then it will undergo reflection, refraction, yes, dispersion, scattering, polarization, and diffraction. Okay. So these are the basic properties of light. So in this session, we will go through the reflection alone. Okay. So what is reflection? The dictionary meaning says something that is thrown back without absorbing it. Okay. So this is an example of reflection. This mountain is being reflected by the water. Water acts as a reflecting surface. So what can we say from here? So we can say that any polished surface or a shining surface reflect. Can we say that? Any polished surface or shining surface reflects. So when we see about the reflection, what is the daily life example that we use, that we see? So we use plane mirrors. Yeah. So when we use plane mirrors reflect, right? We use a mirror. Whenever we step out of the house, we use the mirror to see us whether we are dressed up and we are very proper. Yeah. So when we see mirrors reflect, right? So that's a plane mirror that we use. And this reflection, this process of reflection is governed by two laws. So that is what the laws of reflection. So when there is a mirror or when there is a shining surface, these lines represent that this part is a hard surface, And this only the above part is the shining surface. So whenever the light is incident on the shining surface, this is called the incident ray, I. And there is always a normal, that is the perpendicular line for the perpendicular to the shining surface, normal N. Whenever the light is incident at an angle, the incident ray is reflected back, and that ray is called as the reflected ray, R. So incident ray makes an angle theta or makes an angle I, and reflected ray makes an angle with normal R. Okay. So the first law says that the angle, the incident ray, the normal is the perpendicular imaginary line that is perpendicular to the shining surface, and the reflected ray, they all lie in the same plane. They all lie in the same plane. They are in the same plane. Yeah. So now the second law states that the angle of incidence, this angle of incidence that the incident ray is making with the normal, the angle of incidence is always equal to the angle of reflection. The reflected ray makes an angle with the normal, that is called the reflected ray, and that is equal to the angle of incidence. So angle of incidence is always equal to the angle of reflection. Okay, that is the second law. This is very important, and this we have studied in the previous classes as well. So with this, when we talk about the reflection, we have to talk about the images. When we talk about images, there are two kinds of images: real image and a virtual image. Yeah, real image and a virtual image. So real images can be obtained in screen. Virtual images cannot be obtained on screen. Real images are always inverted, but virtual images are erect. So when we see our mirror in our house, what do we see? We see ourselves, right? But then, is it real or virtual image? The image that is in the mirror is a virtual image. Why? Because it is erect. And when you raise your right hand, it will raise its left hand. Okay, so it's always virtual image. Whenever you move away from the mirror, the image will not be there and it cannot be caught on the screen as well. So the example for virtual image is the image in a plane mirror. But when it comes to real images are always inverted. So when we see movies on a theater screen, that is a real and virtual image. Movies in theater screen. Or any projected images or any projected content is always a real image. Okay. So with real and virtual, we'll see some of the problems on reflection, and then we'll move on. So the problem states that if the angle of incidence is 40, then angle between the incident ray and the reflected ray is. This again basics of reflection. So we know that the second law, which gives angle of incidence should be equal to angle of reflection. So we have to find the angle between incident and the reflected ray. So we'll first draw the angle, the question. There is a normal and we have a incident ray and a reflected ray. So this is 40. We have to find this part of the angle, the whole angle. So now we know that this is 40. With the laws of reflection, I is equal to R, angle I is equal to angle R. We can also say that this angle is also 40, right? If this is I, N and R, this angle is also 40. So angle I will be 40. Angle R will also be 40. What will be the angle between the incident and the reflected ray, this red part? So that will be angle I plus angle R with your basics of geometry. So 40 degrees plus 40 degrees, 80 degrees. So 2 is the right answer, with the angle between the incident and the reflected ray is 80 degrees. Hope you understood this question. Moving on to the next one. A light ray strikes a reflective plane surface at an angle of 56 degrees with the surface. Find the angle of incidence. We have to find angle I, angle of reflection, angle R, angle made by the reflected ray and the surface. Let's take that angle to be Q. Then the angle between the incident and the reflected ray. We know that is with the previous question, it will be angle I plus angle R. So now we'll draw this again. We'll draw this problem. So the shining surface, it has a normal. There is an incident ray and reflected ray. So incident ray is I, reflected ray is R, and N is normal. Okay. The question says, a light ray strikes a reflective plane surface at an angle of 56 degrees. Okay. Then what would be where can I signify this angle? It is between the reflective plane surface and the light incident on it. So this part is 56 degrees. Okay. This part is 56 degrees. So now we have to find again angle I, angle R, and this also. That is the angle made by the reflected ray and the surface. Okay. So this also we have to find. This is angle I, this is angle R, this is, I asked you to keep it as angle Q. Now we know that normal makes a reflective, makes a 90-degree angle with the surface, right? This is 90 degrees. Okay. So to find I, so I can also write angle 56 plus angle I to be equal to 90 degrees. Yeah. Okay. So what will be my angle I? Angle I will be 90 degrees minus 56 degrees. Angle I is 90 minus 56 degrees. Okay. So when I do angle I, what will be angle I? It will be 34. Yes, 34. So if I know angle I, what can I easily find from the second law of laws of reflection? Yes, angle I is equal to angle R. So if angle I is 34, angle R will also be correct, 34. Okay. So I have found angle I, angle R. Then I can easily find the angle between the incident and the reflected ray. 34 plus 34, 68 degrees. Okay. Now I have to find this Q. If you see, the same 90 degree will come here with this reflected ray and the reflecting surface. So I can again write angle Q plus angle R to be equal to 90 degrees. Yeah. So I know angle R, it is 34. So angle Q is equal to 90 degrees minus angle R. So angle Q is equal to 90 degrees minus 34. So 90 minus 34 is 56 degrees. Yeah. So this angle is also 56 degrees. Now see that this angle and this angle are same. Why is it same? What is the principle of this? Yes, the second law of reflection, I is equal to R. Okay. So hope you understood the reflection, basis of reflection, laws of reflection, and how we can apply all these laws in our problems. So we'll see the next spherical mirrors in the next session. Thank you.